Okay, let's talk about something you probably never, ever see. But it's a world that's constantly moving all around us. It's this massive hidden network of pipes and valves that moves pretty much everything that builds our modern lives. Energy, chemicals, you name it.
And let's just get right to the point here. In this world, the absolute smallest mistake, like turning the wrong wheel or opening a valve a little too fast, can cause catastrophic world-changing disasters. The stakes are unbelievably high. So you gotta wonder, right? How can something that looks so simple, just a metal wheel on a pipe, hold so much power? How can it be the difference between a normal day and a total disaster? Well, let's dive in and find out.
To really get it, you have to think of a huge industrial plant as like a living body. And all the thousands of miles of pipes, that's its circulatory system. It's the arteries and veins, pumping all the vital fluids and energy exactly where they need to go, 24/7.
And just like our own bodies, this system has some pretty basic but absolutely essential building blocks. You've got the pipes, of course, the arteries. You've got flanges, which are just the connectors. Gaskets are the little seals that make sure nothing leaks. And then supports hold the whole thing up. Seems simple, but if any single one of these parts fails, the whole system can come crashing down.
Now here's where things get really interesting, the invisible dangers. See, when metal gets hot, it expands. When it cools down, it shrinks. And a really long pipe can actually grow by several inches. It's wild. If that pipe isn't supported just right, that movement creates these incredible stresses that can literally tear the metal apart. That's why operators have to be so careful and warm up the line super slowly.
So if the pipes are the arteries, what's controlling the flow? What are the heart valves of this whole operation? Well, that brings us to the real gatekeepers of the system. Let's meet the different kinds of valves.
This table really breaks it down perfectly. You've got your gate valve, which is basically just a sliding door. It's either all the way open or all the way closed. Then there's the globe valve. Think of this one like your faucet at home. It's designed to let you carefully control or throttle the flow. A ball valve, that's your light switch. One quick quarter turn and it's on or off. Super fast. And finally, the check valve, which is just a one-way street. It's absolutely crucial for making sure stuff doesn't flow backward where it's not supposed to.
And then you have the brains of the whole operation, the control valve. Yeah, there's no person standing there turning a wheel on this one. It gets signals from a computer in a control room, automatically adjusting the flow with incredible precision. This is the heart of modern automation, right here.
But here's the thing. You can have the most advanced, most expensive hardware in the world, and it still won't protect you from the one thing that matters most. Because the real danger, well, it's usually not the equipment. It's the human hands that control it.
You know, when you look at the reports from major industrial accidents, you see the same story again and again. It wasn't that a valve broke, it was simply in the wrong position. A simple human error that managed to bypass every single fancy safety system.
And it's scary just how simple that mistake can be. Picture it, an operator, maybe they're rushed, maybe they're tired. They assume a set of valves is lined up correctly. They don't double check. They start the flow and send a high-pressure chemical into a totally wrong system. And just like that, you've got a massive hazard on your hands.
So how do you stop that from ever happening? The right way. And it all comes down to discipline. A good operator first checks the official drawings and the tags on the valves. Then, and this is the most important part, they physically walk the entire line, putting their hands on every single valve to confirm it's in the right position. Only then, once everything is verified, is it safe to start the flow. That verification step, it's not just a step, it's everything.
And you know, this kind of discipline isn't just a nice idea. It's actually built into strict formal procedures. Let's take a look at how the pros create a culture that is designed to prevent disaster.
So for any kind of really risky maintenance, you can't just close one valve and hope for the best. Professionals use what's called a double block and bleed. They close two separate valves to create a double barrier. Then they open a tiny bleed valve in between them. Why? To drain off any trapped pressure and give them positive physical proof that the line is completely isolated and safe to work on.
And this is all part of a bigger code that these operators live by. Never, ever force a valve. If it's stuck, there's a reason, find out why. Use the right tools, not some rusty pipe as a wrench. Always be thinking about trapped pressure. Stand to the side when you open a valve, not in front of it, and the big ones. Verify, communicate with your team, and document everything. And above all else, never, ever rush.
So when you put all these pieces together, from the simple gasket all the way up to the complex procedures, you really land on one fundamental truth. It's the ultimate key to staying safe in this hidden world.
And this quote just says it all. Good operators respect valves and piping. Discipline is the key to safety. It's not about being the fastest or the strongest. It's about being the most careful, the most methodical. It's about having a deep respect for the power you're controlling. That's what keeps people safe.
What we've looked at today is this incredible world that we all depend on, but almost never see or even think about. So I'll leave you with this question to chew on. What other invisible systems are out there keeping our world running and keeping us safe? And who are the disciplined, unseen people, the gatekeepers, that we rely on every single day?